Hello everyone, this is 13th week class. Today we are going to study moderator effect. What we are going to do is to use a model which appears in Amos manual, right? This model looks slightly different from the previous models in a sense that we have squares instead of oval shape, right? Oval shape is used to represent latent variables, right? In this case, we use squares. These squares are used to represent directly observable variable, right? For example, GPA is directly observable, right? GPA is the grade point average, right? So in this case, we use directly observable variables, right? What we are going to do is we want to check whether gender is a moderator for this model, right? So for example, you create a model for boys and a model for girls, right? And then you compare the relationships between the variables, right? For example, so you will have two different, graphs, right? So suppose this is graphs for boys, okay? And let's say this path coefficient is P1, right? Now, so you are going to draw the same graph for girls, right? And then GPA to academic for girls is, let's say, this path coefficient is P2, right? Once you have done this, you estimate, these parameters, right? You want to check whether, P1 is P2, right? So you want to test, P1 is P2, right? You can do hypothesis testing for other relationships, right? For example, this one is, P3, right? And for girls, same relationship is P4. Then you can test whether P3 is equal to P4, right? If you reject null hypothesis like this, right? So in that case, you can say that gender is a moderator, right? For this relationship, right? So we are going to do this analysis by using the Amos, okay? To check whether you have a moderator effect, right? There are two ways to do this, right? One is to use critical ratios difference. So in this case, it's like a t-test, okay? Now the second one is slightly different from the first method. In this case, you are creating a constrained model, right? Constrained model is, suppose, you want to check, this relationship, right? GPA to academic. You can impose P1 is, let's say, P2, right? Okay. You are going to include, this relationship into the model, right? This model doesn't have, this relationship, right? This model has, this relationship, right? You want to compare, these two models, right? Whether you see the, difference between, these models, right? Let's go through the method 1 first, right? First step is to create separate data files for boys and girls, right? Since you want to see whether gender is the moderator, right? So you create data files for boys and girls, and you draw a model. Looks like this. Okay, your model. You are creating two different models for boys and girls, right? But you only draw once, right? Just you are going to name, differently, right? And you are going to click group number 1. I show you this when we do the Amos, right? And then name the first group by typing boys, okay? So you are going to name group number 1 as boys, right? And you click new, right? You are creating a second group, and you name as girls, and you click close, right? And then you are going to connect to the corresponding data files, right? And then you go to the file data files. You will see the two groups, right? First, you select boys and then connect to the corresponding data file, right? And then you select girls and then you connect to the corresponding data file, right? And you need to specify the output that you want, right? So you go to the view analysis properties and you select, right, critical ratios difference, right? And then you analyze, you need to calculate estimates, right? In terms of output, you need to check pairwise parameter comparisons, right? Once you have done this, you will see the output looks like this. There are the names, right? Parameter names, right? Here. As I said, you are comparing parameters in boys model and parameters in girls model, right? So you need to know the exact names for the past coefficients in boys and girls model, right? In order to do that, you need to go to the output and then you need to check the estimates, right? What I mean by this is boys, model, right? You see the parameter names in here. So let's say GPA to academic, okay? For boys, right? GPA to academic pass coefficient is named parameter 6, right? Now the for girls, right? For girls, for the same pass, GPA to academic, the parameter name is parameter 19, right? So if you want to compare parameter 6 and parameter 19, you go to here, right? Parameter 6 here, parameter 19 here. You will have, t value of 0.398, right? So once you have t values, right? If t value is greater than 1.96, if u alpha is 0.05, then you reject null hypothesis. Okay? So in this case, null hypothesis is no difference between the two path coefficients, right? So if you reject, this null hypothesis, then you can say that gender is a moderator for the relationship between GPA to academic, right? If you cannot reject null hypothesis, then gender doesn't play a role for the relationship between GPA and academic, right? Now that's the method 1, right? Now let's go to the actually Amos. I'm going to show you how we do this. So we are in SPSS Amos, right? Now we are going to draw a graph here. So since we are dealing with the directly observable variable, right? So you are going to use a square instead of oval shape, right? You are going to create a square here, okay? And also you have squares here, and also here and here, right? And we are going to draw arrow here, right? So you're going to create arrow here and here here, right? And also you have arrows from here to here and here to here, right? And you need to have arrow terms, right, for this, and also you have the arrow terms for this, right? And you are going to draw correlations, right? So you are going to create correlation between this and this one, and this one and this one, and also you are going to create correlations here. Let's do the directional change here, right? So you click, okay, so you change the direction, okay, and you click this and change the direction, right? Also you put the correlation between, you know, this one and this, and also this and this, okay, and also you change the direction, and also you change the direction here. Also you have correlation between this and this, okay, and change the direction here. And also you have a correlation between the arrow terms here, right? So you have here, okay. And next step is you are creating two different graphs for the boys and girls, right? So you click group number 1, right? You need to double click actually, and you are going to type boys here, right? Type boys. Then and you click new, and actually you're creating here the second group here, right? So here you have girls, okay, and then you close. Right here you have you know, boys and girls here, right? So you click boys, and you have a, you know, model for boys and girls, right? And you know, you are going to connect the corresponding data set, right? So you go to the file and the data files, right here. So you see here you have two groups, right? So you go to the boys first, and you are going to connect the corresponding data files, right? Here I have, you know, data set for boys, okay, and next you click the girls, and you click file name, and you have a data for girls here, right? So you connected your data, right? Okay, and then you are going to name, you know, these things, right? So you click this one, and you are going to drag the, you know, these names, right? GPA here, and height here, right? And then weight here, and rating here, and academic here, and tract here, right? Right? So you close this, and then you are going to name this one E1. Okay, and also you are going to name this one E2. Okay. Now here, if you go to the girls, right, you'll have same names here, right? So you only put names only once, right? So once you have done this, you wanna specify the output that you want, right? So you go to the view and analysis properties, and you select the output, right? In this case, you click the critical ratios for difference. And you close this. And you go to the analyze and calculate estimates. You name the file name, right? So let's say this one is test2. Okay, and then okay, so it's done. So you go to the view here, right? And then you go to the text output. And you see the estimates here. Here you have, as we have seen this is the boys estimates for boys, right? And if you wanna see the estimates for the girls, you click this one here, right? Girls. So you see here the names of parameters here, right? So you go to the boys, and you have parameters here, right? As we have seen, you need to know the exact parameter names, right? To interpret the pairwise, parameter comparisons, right? You check the parameter names, right? So in this case, GPA to academic is parameter 1 here, right? And rating to attract is parameter 4 here, right? And these are the parameter names for boys, right? So if you wanna check the parameter names for the girls, okay, in this case you have here the girls here, right? And the parameter names here. So for example, the rating to attract is parameter 17, right? Boys, in case of boys, rating to attract is parameter 4, right? So if you want to compare, those two, you 4 and 17, you go to the pairwise parameter comparison, and 4 to 17, 1.983, right? So it's in this case the t value is 1.983, right? So in this case, since it's greater than 1.96, so you reject the hypothesis, right? It's very close to 1.96, right? But you can reject the hypothesis, which is what? The parameter 4 is equal to parameter 17, right? The null hypothesis. So by rejecting that, you can say that there is a moderator effect of genders for this relationship, right? So we saw, how to do the method 1, right? And we are going to study method 2, right? Remember that the basic principle for method 2 is, do you compare unconstrained model with constrained model, right? For the unconstrained model, you don't do anything, right? But for the constrained model, you are going to impose some conditions, right? Suppose this one is P1, right? And let's name the P2 for the girls, right? So you want to check whether P1 is equal to P2, right? Then you are going to impose this condition to constrained model, right? And then you compare these ones and then these ones, right? See if there is a big difference between these two, right? So you impose this for the constraint model, right? If you don't see any difference between unconstrained model and the constrained model, right? So that means what? You don't see any difference between P1 and P2, right? So that's the basic idea, all right? So let's go to the procedure for the Amos, okay? Up to step 5 is the same as method 1, right? And for step 6, right? So you are going to select boys. Remember that we had two models for boys and girls, right? So you select boys, and so if you wanna compare pass coefficients, right? So you select the pass that you wanna compare by right clicking, right? And a small window appears, and then you name the pass, right? For example, in this case, I named the B1, right? And also, this part is very important. So I'll show you this, what this means, right? But anyway, you have to remove the check sign, right? And you go to the girls, you select girls, and then you name the same path, right? As in this case, I named it as G1, right? And also you need to check whether you have a check in front of the all groups, right? And also name the models, right? So you double click the default model and then name that model as model A. In this case, the model A is unconstrained model, right? And then you click new and you create the second model, right? As a model B. And you impose a condition for the constrained model, right? We are going to type in these ones, right? And you go to the analyze and calculate the estimates. Okay? And if you go to the output, you click the model comparison, right? And so you're going to check the p-value, right? Right? So if p-value is less than alpha, you are going to reject, right? This one, right? Model A is equal to model B, right? By rejecting this, right? If you reject this null hypothesis, there is a difference between model A and model B, right? So you can say that there is a difference between two path coefficients, right? That means what? You have a moderate effect here, right? So that's it. So we are going to actually go to the Amos, and I'm going to show you how to do this, right? So we are back to the Amos, right? So we start from step 6 in method 2, right? So let's click boys, okay, boys. So this is the graph for boys, right? And let's say you wanna check this path, right? GPA to academic, right? So you are going to name this path, right? So you go to the view object properties, and you So you select this one, and you are going to name this one as B1, whatever the name is, right? Remember that you need to remove the check here, all groups, right? This one is very important. If you don't do this, it will be very frustrating, right? So you click this, okay? Now let's go to the girls, right? And you are going to name, right? This one as G1, right? In this case, already removed here, right? So you close this, okay? So if you go to the boys, you have a B1 here, right? And the girls, you have a G1 here, right? And you click the default model, right? And then you name this one as model 1, model A. Okay? And then, whatever the name is, it doesn't matter, And you click the new. And let's say this one is model B. And you are going to put conditions here. So B1 is equal to G1, right? And you are going to close. So, and then you just go to the analyze, okay? And you calculate estimates, right? And then you go to the view, right? You go to the text output. And here the results appears here, right? Model comparison. You see here the p-value. It's 0.692. That means what? Since this one is greater than alpha, you cannot reject null hypothesis, right? That means there is no difference between B1 and G1, right? So that means there is no moderator effect in this case, right? For the pass from the GPA to academic, right? Okay, let's stop here and see you next time.